Alright, in this video I'm going to begin to talk about some wave characteristics. So I'm going to talk about transmission, reflection, and diffraction in this video, and in the next video I'll talk about interference and resonance, and probably start to talk also about the Doppler effect. So let's start with transmission and reflection. So these are kind of tied together, and this occurs when a wave encounters a boundary. So it's going to be between two different mediums. So when they interact with that boundary, they can do one of two things. They can either transfer their energy to that boundary, or the energy will reflect off of that boundary and back into the medium from which it came. Most often when an interaction happens, it's not perfectly one or the other, it's a combination of the two of those. So we're actually going to look at examples of what happens when boundaries are encountered. So in this picture you can see that we have two different springs, and just by their color you can tell they're sort of different materials. And so if I were to generate a wave on this spring, it goes and it interacts with this new medium here, and some of the energy from this wave is going to be transmitted to the new medium. So you can see that some of the energy is transmitted over here, but some is actually bounced back and reflected back this direction into the medium from which it came. And notice that this hump is up, right? So this crest is pointing upwards when it reflects from what is considered a boundary that is not fixed, right? So this actually can move in space, right? So this is a non-fixed boundary showing both reflection and transmission. Now, if we had a fixed boundary, like in this instance, and here this is fixed to the ground, and I use a slinky and I generate a wave towards it, once it encounters this fixed boundary, then it's going to bounce backwards, right? And it actually bounces and inverts itself upside down. So this is the reflection of the wave back, and it flips upside down when it encounters a fixed boundary. I'm going to actually show you this using a simulation. So if we look at this, so this is just a PhET simulation, and you see over here I can set it so it has fixed or unfixed boundaries. So let's start with a fixed. And if I just want to generate a wave on this, remember it's going to bounce back and it's going to flip upside down, right? So you see the wave going, and then it inverts itself upside down when it encounters the fixed boundary by reflecting back and forth. Now if I do a loose end, we can see sort of, let's restart it and see what the difference is here. Okay, so you can see that it doesn't bounce upside down. But when it encounters the wrench, which is fixed, then it inverts itself. So it inverts, but then it doesn't. Okay, so that's an important thing to note. Alright, let's go back to the PowerPoint. So we have transmission there, we have reflection, and then the last property of a wave that I'm going to talk about is the idea of diffraction. So waves diffracting is essentially when a wave encounters some sort of boundary, it is going to bend around that boundary. Okay, so you can see that this image is supposed to mimic the barrier islands in North Carolina. So the barrier islands run along the water, or run along, and there's ocean on one side and the intercoastal waterway on the other side. And they sort of protect the mainland from wave action, from hurricanes and stuff like that. So these are like Carolina Beach, Curry Beach, Wrightsville Beach, Topsail, all of those. The Outer Banks. So as a wave comes from the ocean side and it encounters these barrier islands, it will actually bend through, and it actually causes the sand to drag off the edge of the islands, and the barrier islands are actually moving because of this dragging and the current action. And you can see what happens as a result. So there's some friction here and here causing the bending of these waves. Now this can happen with other kinds of mechanical and non-mechanical waves, like electromagnetic waves. And so I'm going to show you an example of that here. So here you have I use light because it's the easiest to tell on the on the simulation. So you're going to generate a pulse of light, and let me just remove the slit for a second. Let's put no barrier and just hit play. And so you can see that this is generating red, wavelengths of light. And if I put one slit in front of it, you can see now that the light is bending as it moves, and it's going to change sort of what frequency and what energy of light is going to strike a screen over here on the side. All right, and we'll talk more in detail about that when how it pertains to sound and light in the next couple of topics. So that covers the first three properties of that all waves have, just no matter the type. So transmission, reflection, and diffraction.